All right, so we're talking about sampling methods, and this is 5 sampling methods, 4 of which are really pretty standard. Okay, so this first one is judgment sample. And so the key here with our judgment sample is that it was your best guesstimate, and ultimately what were we trying to do? What was the ultimate goal of this activity? Good. Find the average, what? Area of these 100 rectangles without having to average all 100 rectangles. Okay, so that was the ultimate goal. And so what I want to do is I'm going to get some of your data and see how we did. And then at the end, I will reveal the real answer, and we'll see how close we got. So while I'm going to write my data down right here in these spots, when I call on you, you are giving me the average of that line. Okay, so when I call on you, you are giving me this number right here. Okay, so let's do the judgment sample. Okay, Sydney, you get to give me yours first.
4.6.
Okay, 4.6.
4.4.
Ooh, 4.4. Okay, go ahead, Grace.
10.4.
10.4. Tyler?
I got 10.8.
18.8?
10.8.
Oh, 10.8, okay. Okay, Allison?
7.8.
7.8, okay. Interesting. Okay, all right. I'm not going to say anything else to get about that. All right, now this sampling method involved randomness. So it did put that randomness component because you used a random number generator, right, to identify those. Okay, so let's have some values that you guys got on those. Clayton?
I got 10.4.
10.4. Go ahead.
11.4.
Brooklyn? 11.4. Okay. Callie?
7.4.
Okay. And Haven? 7. Okay. Cody? Colby. Okay, gotcha. 6. Okay. All right. So there we go. Just wondering what. It almost looked like this was a little less varied than this one. So that's interesting. Well, I don't know. What's the spread from here to here? That's what, 5.4? What's the spread from here to here? I guess less. So interesting, okay? Because we're interested in not only what those numbers are, but I also want to see the spread. You know, how did everybody kind of have about the same numbers, or were there some people that were way different than other people? Okay, that's kind of what I'm looking at when I'm trying to see if it's a good representative method, good sampling method. All right, so let's talk about cluster random sample and stratified random sample. These two are commonly mixed up because they are both grouping methods. And so I want to first talk about that so that we can really make sure we understand the difference between those. So take a look up here. This is the cluster sampling where we had all the rectangles and then it was divided into the 2-inch segments. It just took them and it did it as is. The goal with clustering is that you want each one of these to really the goal with clustering is you want them to be a little mini population. So your hope is that each cluster, and that's what we should call these. We should call these a cluster. I found that, and I'm going to make a statistics dirty word wall. I'm going to make sure people aren't putting just like their regular dirty words up here, but a statistics dirty word wall. And the word group is a dirty word in statistics because it's not specific enough. If I say, well, this group is this and this group is that, that's what are you talking about? In this case, we would call these clusters. And cluster would indicate that these are supposed to be little miniature populations, because with cluster, once you pick one of them, then what do you sample in it? All of it. And because cluster and stratify are common things to get mixed up, then of course that's a song. And so the song that I have it says, hey cluster, you're a group. I will sample all of you. Hey cluster. Hey cluster. Okay. Hey cluster, you're a group. I will sample all of you. Hey cluster. And then we have the other grouping method of stratified. And so let's talk about this. This stratification changed the order of the rectangles, what did it do? Okay, it separated them by size. Very good. So in essence, the quality of the rectangles in the top group is much different than the qualities of the rectangles in the bottom group, and they are different because of their size. We would call this grouping, you wouldn't call it a group of triangles, you would call it a strata from Stratified. And the quality of this, each one of these strata is not a miniature population. Each strata is called a homogeneous group. Okay, stratify, homogeneous. Every single group is homogeneous. Stratify, homogeneous. I get all kinds because how do you actually get your sample from those strata? You take one from each, or you could even take more than one from each. You could take a couple from each strata, but I get you and some of all of you. So I'm taking some from every single group. Okay, so that's the difference between clustering, the little miniature population, and sampling all of it versus stratifying homogeneous groups and getting one from each. Okay, so let's go back up here and let's collect our data there. How am I doing? Oh gosh, time's about up. We only have 1 minute. Dadgummit. Okay, so then we'll finish those little parts there tomorrow, okay? And then we'll play our song so you can hear. Do you know what song that goes to? Anybody know? Hey, Mickey, you're so fun, yeah. Hey, Cluster, you're a group. I will sample all of you. Hey, Cluster. Hey, Cluster. Okay. All right, so we're going to take a look at the regions that you could have selected for your cluster random sample. And so again, for each one of those regions, we'll go ahead and talk about what those areas were. If you averaged this first one, you got 4.42. If you had randomly selected this second cluster, then the average of that was about 7.9. If the third cluster was what you had randomly chosen, then 8.5 is what your average on that one is. The fourth region was 8.1, if that's what you had for your average there. And then the last region was 8.5. So overall, it seems as though several of these numbers are quite the same, and so, they're close together. This one seems to be quite different. So maybe we're centering somewhere around this value, but this one was not really representative. So 20% of the time, you would get a cluster that's not representative. Now, what made this cluster not representative? There were quite a bit of single ones in that group. And so that's what made that representative. If you were, say, measuring for how much tile you needed or something, and these were the samples you had taken, then that would have been bad. You would not have gotten a representative group of data. Okay, so I wrote those cluster values there, and you can see again they're pretty close to each other. Maybe this cluster is not representative. Okay, and then we talked about strata, pulling, you had the homogeneous groups. And so let's get a couple of results that people had from those. One person had a 6 as an average, an 8 as an average, an 8.6, an 8.5 as an average of their 5, and then another person had 7 as that average. So let's take a look at this. Comparatively speaking, these numbers, look at the range of those, from 6 to 8.6. So how does that compare to the variation that we had in these other sections? Yeah, it seems to be quite less. So maybe that's a good thing in that we're maybe centering closer to the real answer. And I haven't told you that real answer yet, so we're going to see how that works. All right, so our last section is the systematic sampling. And so then let's take a look at what happened there. So I know that with our systematic sampling, the randomness came into play because we randomly chose our first number. So that's where randomness comes in the systematic sample. We had a random number between 1 and 20, and then you picked the nth one after that. In this case, we added 20. So the 20th one after that. If rectangle 8 had been my first one, then I picked the 8th one and the 28th one and the 48th, the 68th, the 88th. Those were my rectangles I averaged. So let's get some people's averages on that. So 10.2, 6.6, 9.4, 11, 8.4. So these were some people's averages that we got for systematic sampling. Okay, so I can see we still had some variation from a 6.6 to 11, so still quite a bit there. All right, so now comes the moment of truth. The real answer for the average of all 100 rectangles is 7.42. So that true average was 7.42. So let's take a look at our sampling methods and see which ones seem to be the best, closest to that representative sample of representative of the population of 7.42. And I think we can clearly see that stratified was the best for this situation. And I'm telling you, that happens year after year. Stratified is always showing up to be the best for this situation. Okay? But I wanted to ask you, what is in common? What is something in common with the bottom 4 sampling methods: simple random, cluster random, stratified sample, and the systematic sample? They all contained randomness. And so all of these sampling methods are valid sampling techniques. Sometimes, depending on the situation, one of them is better than the other. And stratified really controlled a variable that we thought we needed to really handle and control. What was that? What did we want to make sure that we got a good sampling of, since this was about area? We wanted to make sure that we controlled the size and that we got one from each of the sizes. We didn't want to leave it to chance. We didn't want to leave it to just simple random sampling, that it would get a good placement or representation of all the shapes. So we wanted to control that so that we made sure we got a small one and a medium one and a large one and so on. All right, so that's what makes these sampling methods valid. Now, I'm going to tell you up here at Judgement Sample, these two right here and the 4s, boy, those really surprised me that those showed up. Because typically I get numbers like, 14.6 or even, 10.4, like I said. And what happens with that judgment sample is a lot of times, it's your best judgment. But still, we are more likely to see the larger rectangles and choose those ones just because our eyes see those larger ones. And we don't notice that there's a lot of the very small rectangles that bring the average down. So typically with these judgment sampling, I'm getting choices higher than, in the higher realm rather than the smaller. All right, so that concludes what we got to in our sampling methods. So you have no homework tonight, and tomorrow what we are going to do is, of course, listen to our stratify and clustering song, and then we will go over page 8, which defines each one again as a review and gives the advantages and the disadvantages of each sampling method.